Hello students, in this video we'll discuss the direct comparison test. Let's suppose that we have two sequences of positive numbers. A(n) and Bn. The first relationship says that if An is less than or equal to Bn, and the sum, n goes from 1 to infinity, of Bn converges. And remember, these sequences are positive. Then the sum, n goes from 1 to infinity, of An converges. So let's see an example of this. Let's show that the sum, n goes from 1 to infinity, of e to the negative n cubed converges. And so what we'll do is we'll observe that if n is bigger than or equal to 1, then n is less than or equal to n cubed. Therefore, if I flip the signs over here, I have that negative n is bigger than or equal to negative n cubed. And if I exponentiate this relationship, we have e to the negative n is bigger than or equal to e to the negative n cubed. So if we consider the sum, n goes from 1 to infinity, of e to the negative n, this is a geometric series. This looks like the sum, n goes from 1 to infinity, of 1 over e to the n. And this series over here converges by the geometric series. Test. Now we can apply our result here, our direct comparison. So this, of course, is called the direct comparison. So by direct comparison, we see that our series converges. Hence, our series converges. The second part of the direct comparison theorem is the following. If An is less than or equal to Bn, and again, remembering that for the direct comparison we need positive terms, and the sum, n goes from 1 to infinity, of An diverges, then the sum, n goes from 1 to infinity, of Bn diverges. And so these are easy to see. If, for example, we wanted to show the sum, n goes from 1 to infinity, of 1 over 3 root n diverges, we could compare this. We could say that 3 root n is less than or equal to 3n if n is bigger than or equal to 1. And taking the reciprocal of this, we can see that we can consider the sum from 1 to infinity of 1 over 3n. And this is a harmonic series. And this harmonic series we know will diverge. So since this harmonic series diverges, and that our sum over here is in fact bigger than this sum, we see that this series must also diverge by the direct comparison test. Thank you very much.